Hello, hello. Hit the wrong button there, but hello, how's everyone doing? It is Friday. It's not Saturday, it's Friday night. Well, afternoon. It'd still be evening, depending on where you are. How's everyone doing tonight? It is Friday instead of Saturday. I won't be doing a stream tomorrow, okay? I'm doing the stream today. Tomorrow, I got family stuff going on. I don't know what time I'll be back. I don't want to do this, push the stream back later. I know it's already late for so many people. So we're doing it Friday. I think it's a holiday for most people. It's a holiday for me. That's why I can do it. So tonight's stream, I'm jinxing myself here, but this might be the last stream before Toasty Boy. I've got one big box here I got to open up, and the last box I'm waiting on should be in Friday, according to DHL. And that's the LDO stuff. That's the frame, the rails, etc. The stuff that we need for actually building the printer, because I can't hang parts on nothing. Holiday. Yes, it's Good Friday. I guess that's a holiday. I don't know. I just had tacos. And I'm not working, so I'll take it. I'll take it. Ooh, I don't like where that box is. Let's move that box over there. Somebody didn't like the fact that I had chat up here, so I moved chat down here. So hopefully it's working. So yes, so tonight's stream should be pretty straightforward. Max relax. I got a Hotend here I'm going to try out. And I've got a box of parts from Fermio Lab that I have actually gone through them already just to make sure it was all there. He was kind of worried to make sure that he didn't want me opening it on stream and finding out somebody screwed up shipping. So I did take a peek through it, but we'll actually go through it all on stream. And we'll get this guy printing. And we'll talk, because I got to start printing parts for Toasty Boy. So, today's stream is brought to you by you. That's right. For all the Patreon members and YouTube members and anyone who's ever donated to the stream tonight. Or just anyone who just likes watching this stuff. Tonight's stream is brought to you by you. And the letter A for awesome. Because that's what you guys are. Have I seen the new SKR2? I have seen the picture that they shared, and I have seen, I might have seen the specs. I may have been slightly privy to that. But other than that, I've seen it, but it's way too new to say. The price point of $38 before adding stepper drivers, when you're comparing it to the Physec Spider, kind of puts a damper on it, put it that way. So anyways, tonight, the big attraction will be this guy. Ooh. So this right here is the Phaetus Dragonfly HIC Highflow. This is their new Highflow Hotend. When they wanted to send this to me, they told me they were coming out with a Highflow Hotend for the Dragonfly. I said, sure, send it to me. So I didn't even know what this looked like when they sent it to me. So this is what showed up. Johnny, $5. Thank you. Appreciate it. For the stream. Thank you. The stream is for you now. So anyways, so this is what we got. It is very volcano-esque with the vertical heater block there, but that does give you a larger melt zone. So for those unaware, high-flow hotends, like the Slice Mosquito Highflow or even the Dragon Highflow, they extend the heater, the melt zone up into the heater block or into the heatsink area. So they shift up, so you don't lose any Z. Versus setups like this and the Volcano, where you just have the block vertical. Now, the Volcano outperforms these in terms of max output. So this is going to be interesting to see how well Phaetus's version of it does. And they have done quite a few things differently. Some things I didn't even know about until I had this in hand. Okay. So let's take a look at this, because there's some funky stuff with this. And hopefully this works. Because by the way, this mount right here that I'm going to be using to mount it is literally the only one. Eddie, the engineer, catted this up this morning, and I just pulled this off the bed like 3 hours ago. And I told him I wouldn't test anything, and I was going to do it all live. So hopefully this thing actually works for holding it, and we do get some airflow. But this is literally the very first test of this mount. So who knows? Let's get some music going. So anyways, so this is the Phaetus Highflow. So I have the one I got, actually, I've had this for about, I don't know, over a month now, but I was waiting on them to send me some stuff before I actually put it in. Because the one it comes with a hardened 0.4 millimeter nozzle. It's a high flow hot end. Give me some fat nozzles. So I have 2 nozzles here. These are 0.8s and 0.6s. So you do have the option of a copper nozzle that's plated or a hardened nozzle. Okay. So we're going to try the 0.8 millimeter copper nozzle plated. So the plated copper nozzle. Matt 99. Thank you. Appreciate it. Yeah, Eddie knows all about FT5 to Voron conversions. So let me grab a volcano nozzle. I know I have one somewhere. Oh yeah. And the joys of being a YouTuber, this randomly showed up too today, or a couple days ago. I got a Fly CDY V2. I gotta find something to put that in. Okay, so let's see here. So the biggest direct comparison would be a volcano, which I think I have somewhere. Do I have a volcano? I have volcano nozzles. Let me see if I can find a volcano. I know I have a volcano. Yeah, there it is. There's a volcano. So I want to do a comparison. The coating came off the nozzle and clogged it. That is news to me. I haven't seen that before, and I've used a lot of... Now, normally, most of my copper plated nozzles are Triangle Labs, but I have a Phaetus one in... I have the Phaetus copper plated nozzle in my switch wire, and I haven't had any issues with it. So, contact them about it, I guess, and see if they'll send you another one. So... just to compare, tear that off, 0. So this is a volcano. Now this is a, I think it's a Triangle Labs volcano, but this is a volcano. What is that? 35 grams. And here is the Phaetus. 58 grams. So, copper block for one. So copper block and a massive melt zone. This should be able to output quite a bit of heat, so we shall see. And then nozzle wise, just for comparison, it's a longer nozzle. Actually, let me pull up close to the camera. So it's a much longer nozzle, and the heat break. Now, I don't know about this. This is the first time I'm using any of this. The heat break is actually integral to the nozzle, okay? So the heat break goes all the way up and connects to the heatsink. And so this is all one piece. So you probably are going to see a difference in price, obviously. William, €10. Thank you. Appreciate it. I think you're about to buy and start 2.4 build. Good luck. Hope it goes well. So anyways... they have the integrated heat break in the nozzle. Now, that has a good advantage because you should never have to worry about leaking at all with this setup. So, and as John says, ladies love the long nozzle. So, you should never have to worry about leak, like any oozing with this type of nozzle, because by the time it gets all the way up here, you're in the heat break and the plastic should not be molten at all. So let's put this guy in a printer. So right now I have the 0.4 millimeter nozzle. Now, when it comes to nozzle swaps on this, it is a bit different because I can't find my Allen key that is the right size. It's the right size. Now this is one downside. You can't change your nozzles on this quickly. You have to undo this set screw, take the heater block off, undo your nozzle, all the way. Take your new nozzle, screw it in all the way. I guess tighten it to the block. And then you put it back in. Now they're kind of smart here. Instead of the set screw pushing directly on this very thin pipe here, I think it's stainless steel or titanium, I don't know, and crushing it, there's actually like a little insert here that's got a groove in it. That actually is the compression fitting. So that goes in like that, and then you tighten it. And that's how it works. So you should never have to worry about oozing with this. So this is just, I don't know. I've never tried this setup before. This is completely new. I haven't seen any other Hotends that have this setup. So we'll see how well it works. Yeah. So let's get some stuff in here so we can actually use it. How am I missing all my Allen keys? I haven't even started the stream. I'm missing stuff. So we have, I'm going to use a, what is this? It's a Triangle Labs 24 volt 50 watt heater. That's just going to go in there like that, I guess. Put it like that. Only 50 watt. Well, here's the thing. You can only put so much heat into this anyways, right? There's so much thermal mass here that 50 watts will heat this up just fine. Like, I've seen there's like 100 watt heaters. There's really no point to that because you can only take the advantage of the 100 watt if you're pushing so much filament through here that it's literally sucking the heat right out. Which, considering most of the time a copper or an aluminum block can keep up with most printers, and copper is so much better, I highly doubt you're going to really need anything more than a 50 watt. Okay, and then I'm just going to use a, what is this? This is a Beta 3950. Nothing fancy. For the thermistor. Thoughts of going 12 volt, 120 volt? That's a little too much. Oh, for 50 or 80 watt. Honestly, I've never had any problems with 50 watt. 50 watt has been my go-to, and it's more than enough for the average home gamer. So, now, mine didn't come with a sock. They advertised it as coming with a sock. Mine didn't come with a sock. Mine's a pre-production, so who knows. So I need to get some heat sets now, which means I got to back in here. I need to move that. I got my little acro bin thing kind of blocking. I don't know what that was powering. Hopefully nothing important. So, okay, Formbot. I'm going to say something about Formbot here because a lot of people are buying the Formbot kits. They've already started swapping out components, okay? So I'm seeing people get Formbot stuff with random motors in it. They're not LDO motors. They're getting like literally random motors made in 2011 I've seen pictures of. And they're not shipping with the SKR 1.4s. They're shipping with 2 trees 1.5s, SKR 1.5s. So who knows what that board is? We've never tested it. We don't know if our config works with it. Yeah, because you got to remember, if you follow the sourcing guide, most of that stuff you can get from AliExpress. Now, Formbot's kit is several $100s less than if you source it yourself from AliExpress. they're saving money somewhere. Put it that way. So we're already starting to see people get kind of burned. So take it as you will. I can't stop you from buying a kit. But I know everyone's jumping on the Formbot kits after Stefan's video. And yeah, people are starting to get burned. Because you got to remember, pretty much majority of those kit suppliers are just kind of walking through Shenzhen or wherever and just grabbing anything they can in bulk to fill out the bill of materials. The only ones that really like LDO, good stuff. Magic Studios, they have a channel on the Discord. They listen to feedback and they've changed some stuff and upgraded some stuff on their kit. So their kits are pretty good. But there is no approved endorsed kits. So be prepared to swap stuff out. That's all I'm saying. And if you do have a kit from Formbot or any other vendor and you have problems with it, let us know. Because if anyone starts like sourcing kits and there's like straight up unsafe or really super sketchy stuff in the kits, we really want to know because we'll put them on blast or at least, you know, pin posts about it in the Discord. We don't like seeing people get burned. Should be all the heat sets. Kenneth Thang, we live in the same city. You want to do a live unboxing? You can arrange and pick it up off you. What? DM me on Discord. We'll talk about it. What kit is it? Because I won't build your printer. Yeah, I got stream beats going. Why is it not playing? Oh, there we go. I got the music playing. Turn it up a bit. All right, you guys want the lo-fi? They have house music. I can play house music if you guys want. It's a Formbot. It is playing. Okay, I turned it up a bit. DM me. I'll talk to you after on Discord, Kenneth. So just hit me up on the Discord and we'll chat. Because I would love to actually take a look at those kits. Just to see. House music? Okay, Andre wants house music. So this is actually new. So for those unaware, I play stream beats during the streams because I don't get copyright strike for it. So they just came out with house music. So let's give it a shot. Anytime you put heat sets in, you want to make sure there's no, the plastic usually has a tendency to rise up. Who is that? Andrew Rogers, thank you for becoming a member. So let's put this together. Let me grab some screws. And see how well Eddie the engineer can design a Hotend mount. So if this doesn't work, make sure you yell at Eddie. Where is, God dang it. I'm missing the one Allen key I need right now. Oh well. Random kit Allen key to the rescue. Okay, that doesn't work. 16 mil. He said something about these having to use 16 mils, so I might have to drill this out. We'll see. Yeah. The joys of having a first revision of something. Hey, look, it actually fits in there. Perfect. So, steal the screws from here, because why not? Yeah, gotta clean out some holes. There we go. And I'm probably going to have to make a new Bowden tube for this too. Well, it's going together pretty good. I did forget that I recently changed some profile stuff. So I gotta tweak some stuff here. It's a little, my whole inner diameters are a little tight. What are your thoughts on PETG as the interim for ABS parts until the initial setup? Honestly, it's not hard to print ABS on most machines if you can put it in a cardboard box. I've done the print-to-printer in PETG and then rebuild it in ABS. It works. It just kind of sucks and it's a pain in the butt that you got to redo everything. So if you can, just go straight to ABS. But I've done it. I did that on my V1. And my bed mount was already starting to melt. Am I starting 1.8? No, I am not. I hopefully will be starting it next week, though. I should have... The only thing I'm waiting on is the frame and the LVO components. So the motors, the rails, and the frame. And that was shipped from Hong Kong yesterday. So that should be at my house Friday. So hopefully next Saturday we could put the frame together. Hopefully. Which way does this go? It's gonna have to go in there, like that. Now I gotta tighten that. So it's gonna come up there. Okay, so we're gonna have a little bit of a yeah, I can go like that. That can go there. That can go there. Let me find some zip ties. Hopefully I have some more small zip ties. I'm gonna run low on zip ties. I gotta restock. Which way does it go? The wrong way first? Well, if I put it in the other way, I'd probably be hitting plastic with this. This sits really close to the plastic. Like there is a millimeter gap, maybe? Inches, millimeters. There we go. 1.5 millimeter gap. That is really close. Eddie, just so you know, this block sits really close to that plastic. So it's okay. I got my little fire extinguisher in here. If we start burning stuff, I'll kill the power, fix it. First revision, right, guys? First revision. So on the bright side, these wires are never going to get in the way of the fan ducts. That is a big hot end. Okay. Got that there. In here so I don't lose this stuff, and now I just got to wire it up and we can throw it in the printer. Oh, there's my Allen key I was missing. Those ducts too high. They're on the same plane as the regular ducts, so we should be okay. There's quite a bit of a gap there though, because the it's a narrower block. This was literally a quick hack together Eddie did, so we have no idea how well this is going to work. This was literally revision 1, just so we can get this actually in a printer to see how it behaves. The frame will be unchanged for 0.1, Eric. You don't need to worry about the frame changing at all. Do I heat treat the ABS? No. I just printed it. This literally came off the print bed 3 hours ago, and then it's been sitting on my shelf until now. Rippers out here, or are they in my drawer? They are in my drawer. I hate crimping fiberglass insulation. It's annoying as heck. Yeah, crimping. Oh, just you guys wait. I got something special for the 1.8 build when it comes to crimping. And I'll be able to show you guys that once we get this printing. I got a box here from Fermio Labs with a bunch of 1.8 parts in it. I'll go through that. What kind of connectors am I using, Andrew? And again, thank you for the $5. It's a these are Molex Microfit 3s. And for a crimper, I use the Engineer PA09. I like my manual crimpers more than the ratcheting ones, I find. That's just personal preference. No, this is not a Nova clone. It shares 0 parts commonality with a Nova. It does have the downside of having proprietary nozzles, which I'm not a huge fan of, but at least their design kind of justifies it because they have an integral heat break with the nozzle. So it's kind of their own special thing. So I give them some credit for that. It's new and neat. So we'll see how it works out. Because when they asked if I wanted one of these, I didn't even know what it looked like when they did the initial, hey, do you want this? Okay. So, we have it put together. Got it wired up. Yeah. Hopefully everything works out. Oh, I need to figure out how long of a PTFE heat break, because okay, so another thing, I was originally actually going to put a Galileo in here. I have all the parts for the Galileo printed off. I was going to put the Galileo in here and run this with the Galileo. The problem is I didn't realize the Galileo needed the 8mm ID BMG gears and bearings that I don't have. So I'm waiting on stuff to come in. But I am going to be actually putting the Galileo in here because this LGX, I got to send back to Nimgria. Sorry, I keep delaying it. I like it too much. So the Galileo is going to go in here. This LGX is going to go back to Nimgria, who lent it to me to do the testing and whatnot, because... yeah, what is it? I have another LGX that this is going to go in Toasty Boy. So I'm actually going to put an LGX in Toasty Boy. I think this will last better at the higher temperatures than the Galileo. I don't know for sure, but I wanted to put the Galileo in here. So the LGX is going to go in thing. So I need to make a new floating piece. I got to figure out how long that's got to be. Actually, wait. I'll do this the easy way. I'll do this the very easy way. Take that off. Oh no, because I got the whole thing off. I don't want to take the whole thing off. Screw it. I'll do it the hard way. Too lazy. So I need, because this is longer. Eric Hellman, SEK 119, whatever that is. Thank you, appreciate it. Your streams are highlight of the week. I tried almost everything to solve y-axis ring on my V2, but no luck. If I asked you to produce y-axis ring on your V2, would you be able to do it? Y-axis would be going that way. There is a lot more mass moving on your y-axis than your x-axis. On the x-axis, it's only the toolhead. On your y-axis, it's the toolhead and, you know, the whole gantry. So by default, you are going to see more y-axis ringing at higher accelerations. You got to remember, most people run their borons at higher speeds and accelerations than most people on their enders ever do. So you're going to see, you're more likely to see issues at these super high speeds that we guys run all the time because the machines can handle it, but you're going to see, you know, higher risk of ringing. So what I would recommend is do your input shaper tuning, because that will allow the machine to cancel out what's causing the ringing. Because it's very hard to say because everyone builds their machine a little bit differently. So. Where is my X-Acto knife? The Highflow Dragonfly, it's, you know, functionally, or how do I put this? Cosmetically, it does resemble the Volcano, like just from the construction, the outward construction. But from what seems to be the big selling point on it, it has an integral heat break into the nozzle. So, when you look at it, put one up close here to the camera. So this is one of their hardened ones. Focus. So the nozzle has the heat break centered into it. So it is one unit. So that means you should have zero issues with oozing at all. And the nozzle extends all the way to the top of the heater block, instead of having like a titanium heat break come partially into the heater block. So you have an even larger melt zone. So on paper, this should be able to output quite a bit of plastic. Rem, $5, thank you, appreciate it. Loving the eSun ABS Plus without an enclosure. What other ABS is close in terms of easy printability? So far, eSun colors available. So yeah, eSun ABS Plus, colors are kind of poo-poo. They make a good black. It's a nice matte black. Like that's what I use as my plastic. But in terms of other plastics that print like it, any ABS, low warp ABS is kind of common. I haven't tried any other brands though. So how much of this sticks out is the question. Let's find out. Okay, so it's got to go there. That's tight. You kind of do want your bottom too tight. There. Hopefully that's enough. Got the right camera? Yeah. Oh, wait. Whoa, 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 whoa. Ooh. Okay. I know this isn't Twitch and there's no point, but 50 points to get whoever guesses what I just forgot to do. $50 points to whoever guesses what I just forgot to do. I'm putting in a longer nozzle, or a longer hotend. Thermal paste, no. Adjust the probe. Ryan's got it. So, yay, go gadget crappy mobile cam. Because you got to drop your probe. Otherwise, when you go to home, you're gonna have a bad time. I don't know if this is too low. We'll find out in a minute here. Oh wow, I gotta drop it even lower. Hopefully I have enough. This looks so weird. Turbo. Fight Club rules. Okay, good enough. I triggered your oh, hey Google? Hey Google. Hey Alexa. Okay. Hey, look. Okay, Eddie, everything lines up. Eddie should be all happy. Everything lines up. You're good. Okay, so just to give you an idea, that's how much lower it hangs down. That hangs down quite a bit lower. Hook that up. I just realized, crud. So, male-to-male connectors don't work. So, one second while I rewire a connector. Slice engineering copperhead would be good end for forend. There is no copperhead mount. There's unless somebody modded one. There is no official copperhead support on the Afterburner toolhead with the copperhead. Simply for the design team doesn't, well, put it this way. The copperhead is a step back from the Mosquito. At its price, it's hard to justify. Because the Mosquito is so much better, and at lower price points you have dragons that are better. So, yeah. Okay. That is that. I don't know where my cable cover went with this guy. I used to have a little, I printed off the temporary cable cover for this. I don't know where it went. That's okay. I don't need to get a serial for this, so we'll skip it for now. Get some power to it. Did something pop? Oh no, I just don't have the power on. Okay, 1, 2, 3. On crappy home Wi-Fi, do your thing and not work. Oh, there we go. Oh wait, this run's still running Octoprint. It takes a minute for it to boot up. My bad. Okay. Octoprint takes forever to boot. Oh my god. Okay, so we are getting temperatures. Tool's a little warm. That's fine. Temperatures. Oh. Now, Eddie told me that X and Y position of the nozzle is unchanged. Best not be lying to me, Eddie. Okay, Eddie didn't lie to me. Now, we find out if the gantry tramming works and our probe is at the right height. Otherwise, we're going to have a bad time. So what I can actually do is I could just YOLO it, but I'm just going to move it down and hopefully the light comes on. Oh, I can't see the light. And the light's on. Okay. Okay. Terminal. Quad gantry level. Huzzah! Cool. We're good. Eddie? It works. Okay, we need to print something, guys. Let's find something to print. So what do we got in here? We got a 0.8 millimeter nozzle, right? So we got a 0.8 millimeter nozzle. So we're going to print something at 0.6 millimeter. What should we print? What should we print? Somebody give me something big to print. And I am going to try and find some plastics. Holy heck, I am running low on plastic here. Have PLA left? I've got black PLA plus. I've got a little bit of rainbow, some red. Oh my god. Woe is the day when I'm low on PLA. Okay, red it is. That's like all I got. I am running so low on PLA. I've got some coming. I bought a bunch, which I'll talk about later because I ordered some stuff for Toasty Boy. I'm gonna try. And then I did order some PLA, and then I think somebody's sending me some, so we'll see. Devoron Red? No, this is generic Amazon, whatever was on sale, Pro filament. It doesn't want to go into the Hotend. Yeah, that's all of it. Okay. It's there. Click. Let me PID tune this, by the way. So temperature, control, home. And let me actually make sure that I actually, because it's a beta 3950, and I think I previously had a beta 3950 because a lot of my probes are beta 3950s. But let me just double check in the config that I have it called out as a beta 3950. Here, bed, extruder, thermistor, beta 3950. Yeah, so we're good there, right? Yeah, NTC 100K beta 3950. Okay, so we're good there. So terminal, PID tune, target, and we'll go for 220. Hey, the fan works. Nero, how about printing Voron tool changer parts? I don't have any PETG, so I can't print the Voron tool changer parts. Giant Prusa pug. Why are people wanting me to print Prusa parts? But Turbo, $5. Thank you, appreciate it. Any unnecessarily large Voron part? I could. What's the thing on the Ender 3? That is can you see? Oh, you can see it. That is, I was testing out the H2. I'm having issues with the mount though. It's not. This is the Spaghetti Detective, I guess. This is with the H2 on the Ender 3 running rep firmware. So yeah, so that's PID tuning. Hey, it's heating up. It's heating up. Yay. Let's find something to print. Maker's Muse Easter egg. I could do that. I could do that. Big bunny. Oh yeah, it is Easter. It is Easter. So let's do an Easter egg. There we go. This looks funky. Let's do this. Yeah, let's do that one. See how that works. There's loopy, there's crushed. There's quite a few of these. Well, I'm smelling multi-plastic, so it's heating up. Yes, I have a 0.8 millimeter nozzle in it right now. So right now it's just PID tuning. So we gotta kind of let it do its thing here. There's a lot of thermal mass here. I told it to print, go to 220, it's jumping to like 230. So there's a lot of heat there. So bring in that. And let's scale it to, how tall do we want to print? Let's print at, I don't know, can I get 300 millimeters? Yeah, let's try 300 millimeters. I don't know if we can get 300 millimeters out of this guy, but we'll see. Here one. So we have a 0.8 millimeter nozzle. We're going to do vase mode. We are going to do vase mode. Because honestly, vase mode looks the coolest. At 0.6 layer height. Don't forget to change. Well, the nozzle is still set in Clipper to 1.2 millimeters, so we should be okay. Let's try over extruding that a bit. First layer, over extrude. We're going to over extrude a bit on purpose, just to make sure it looks pretty good. Cooling, 100%, yeah. Print with 2 bottom layers just in case. I would love to see a flow rate comparison. I have never run a volcano. I have a volcano. It's a Triangle Labs volcano, but I have a volcano. I've never used it because I got this. I bought this back when I was running a V1.8, and now with the tool heads not really being the greatest for these kind of hot-end assemblies, I never really used it, and now I've got high flow dragons and this guy, and so it's kind of like old tech. Technically, this should outperform. It's got a copper block and a larger melt zone. So on paper, this should have no problems outperforming a volcano. Yeah, so right now it's just doing the PID tune. Oh, that ain't gonna work. This egg ain't gonna work because it doesn't have. Actually, it may work. Let's see. Slice now. How much are they claiming? I actually haven't checked the docs to see exactly how much they're claiming. Yeah, whatever. We'll let this roll. Export G code. Save underscore config. Boom. Bed to 65 and upload the G code. 63 millimeters a second on the Dragon Highflow. I've pushed about that ABS. I've pushed that. Can I tune my Ender 3 Pro into a Voron printer somehow? The closest you could turn an Ender 3 into, reusing the most, would be turning it into a switch wire, which is this guy right here. There are some mods for it. I think it's the Grizzly or Grizzle mod that people have done. So it can be done. Yeah, the movement arm of the volcano and the heat break is yes. So for those unaware, all this extra mass hanging out of the bottom is wholly supported by just the heat break, which that is more of a problem on this one too, because it's a thinner heat break. So you really don't want to crash these nozzles. Otherwise, you're gonna have a bad time. Am I printing with a brim? Yeah, I am printing with a brim. Okay, that'll be. You gotta remember too, you know, like, even if you have a hot end that can push a crazy amount of plastic, you're still limited by the fact that you have to cool the plastic and extrusion characteristics, and the fact that like you're extruding a semi-molten plastic. So as you move the nozzle along really quick, especially on like sharp corners, you'll have a tendency to just drag the plastic with you, and you won't get clean prints. So you can easily outrun, these printers can outrun standard hot ends, no problem. And the prints look like poop. Like I've done speed prints, like here's a benchy at what are we doing? Like 300 millimeters a second on an Ender 3, and it's all under extruded all heck and back because like plastic just can't handle it. Plus this was a stock Ender 3, so. You've seen videos. I've done an a 9-minute benchy on V2.26 back there. Yes, you can push those speeds on a printer. You got to understand though, remember, most of the time when you see people printing at those stupid speeds on a printer, they're printing in straight lines, because prints, like any actual print, like a geometric object, looks like ass when printed at those speeds, or you're blasting it with so much cooling that the parts are usually pretty brittle. So that's like the speedboat benchies. I have fans pointing at my printer to try and get the cool the ABS down, because you have to print with like ABS, because PLA at that high volumetric rate does not print well, does not extrude well. So a lot of the time people are printing like a good quality ABS and they're having to blast it with cooling, which with ABS, that ain't the greatest thing. We got to remember, like, you got to think of it like injection molding. When you injection mold, you shoot all the plastic in at once and you let it cool slowly to a certain point. Then you take it out of the machine and then you let it cool back to room temperature gradually. You don't want to overcool something. That's how you get warp prints, deformed prints, etc. Let's back a bit. All the room I can get in a minute here. Yeah, right now I think the fastest benchy I've seen, it's like, I think around 6 minutes, and that was done on a Delta. Deltas are the quickest kinematic for a reason. Like, it's just the way it is, but you're still, you know, well beyond home gamer at that point. Plus, you're not printing plates full of ABS parts at those speeds. Usually speed prints are small, quick objects. You're not printing for 12 hours at those speeds. Vase 3D. Yeah, I've seen that video. His printer looks a lot like a V1, but, so the hot end doesn't really matter. It's just a block of metal melting plastic. I'm sure this could do it at those speeds too. 400 millimeters a second, 50K XL. That's quite a bit for NEMA 17s. I'm assuming he's running Clipper with some beefy steppers and a very high current. I wouldn't want to run my printer that fast all the time. Plus, if you look at what he's printing, it's a rectangle and it's already kind of looking like crap. Like, they're not practical things. It's like driving a Ferrari to work every day down the highway when you're stuck in traffic for an hour each way. Yeah. It looks really cool on paper, but practically it really serves no purpose for the most part. But it just looks cool. That's why I did the one video and then it became a whole contest and I'm like, okay, whatever. Control. Print. Servos instead of steppers. Well, here's the thing. With NEMA 17s, you can already outrun most hot ends. So why do you need to spend more to go to steppers when you can already outrun the hot end? Yeah, Mura, most injection molds are water cooled. Like there's water cooling lines through it. Depending on the plastic, you do have some that use like oil because some plastics need a hotter temperature and water can't work at above 100 degrees. 100 millimeters a second. The first Voron V2 ran at a maximum of 100 millimeters a second because it ran on Marlin. So imagine 8-bit Marlin trying to handle running 7 stepper motors at once. Yeah, bolted to the wall, I believe it. All my benches here are bolted to the wall. Like, all my benches here, these are all bolted to the wall. Okay, let's see. Do I get plastic? I didn't prime this at all, so hopefully there's plastic in there. Oh, we're getting plastic. Yay, plastic. Oh, wrong camera. Okay. Also heat up, and then it should go do its thing. Oh, Spaghetti Detective. Hello. Thanks for, I don't have a Spaghetti Detective address. I don't run Spaghetti Detective on any of my machines because I run Clipper using mainsail or fluid. So unfortunately, there's no Spaghetti Detective support with those. But I do like what you guys do. And the moment it comes to mainsail or fluid, I'll be all over that shit. Yeah, the Nova Hotend. Yeah, I've seen it. The guy tried getting me to get one like ages ago. He kept popping in my chat. And at the time, I'm like, it's a shiny volcano. Even this is basically a shiny volcano, but it's different enough that I figured I'd give it a shot. But this has the same thing where you have the heater cartridge is parallel to the filament path. But they have the integrated nozzle. How much acceleration am I running here? Speeds and feeds. Where's my speed? Oh, I'm running like 3K XL on this guy. And I don't have input shaper. This is going to be fun. Yeah, speed printing is like... Pedro's got a good point. It's like the crazy overclocking. It's really cool to watch. And it makes a good YouTube video, but in real world, like day-to-day operation, it's not exactly commonplace. Got 400 people in here? Oh my god. Hi everybody, how are you all doing? Once this print gets going, I got a box here of stuff from Fermio Labs for the V1.8 build that I'm gonna unbox. My first layer is looking a little close, but I'm not too concerned. Let's try going up a little. And I just realized I didn't tune any of my speeds. I did not set any speeds for this. How fast am I going? 30 millimeters a second. Okay, so it's still the same speeds that we ran with the last Vase mode, which means speed, flow rate, flow. How much flow am I pushing? Volumetric flow rate. Oh, we're not pushing a lot. We're pushing like 30, I want to say. I'll bump the speeds up. Sorry guys, I forgot to bump the speeds up from the last time we were doing a 1.2 millimeter nozzle. We only got a 0.8. Doggo. Let me go see if Doggo's outside. Coda! Coda! He's coming. How do you see the flow rate? If you got Prusa Slicer, you have an option. Come here, Coda. Get your doggo butt over here. There's the doggo. Come here. Oh, he's like a boy. There you go, Das Boot. Yeah, I know. Mom is upstairs, and you want to stay upstairs. Okay, what? You're leaving already? Oh, okay. 1 second. I gotta say goodnight to the little guy. There we go. Yeah, the first layer is a little thick, but it's fine. How you calibrate a brand new printer perfectly in Clipper. Z-Bell, Z-Tilt, bed mesh calibrate, and Z-Height. So what I would do is, Nerq, $5. Thank you, appreciate it. Spaghetti Detective, please add mainsail and fluid. It's more on the mainsail and fluid side of things, I think. Not the Spaghetti Detective, I believe. I'm not 100% sure. I am not a software guy. But in terms of what I would go through, first you want to make sure your Z printer like this, a V2, or any gantry tray made printer. Turn on XYZ home, and then you do your bed mesh calibrate to make sure your gantry is trammed to the bed, and then set your Z offset. That's the order I do, because if you set your Z offset before you tram out your gantry, you don't know if it's consistent. Can't you run both? Not really. You would need to swap out the SD card on the Raspberry Pi, I believe, because I use Mainsail OS or Fluid Pi to install it. I don't use like Kiao or whatever it's called. JST STM versus Molex Microfit 3. If you're doing wire-to-wire connection, Molex Microfit 3s. That's my go-to. JST is like connected to a board, I believe. And then they have the wire-to-wire JST I've never used, but I like my Molex Microfit 3. But I don't swap between the different interfaces. This one is the only printer I still have that runs Octoprint, and it's running old Clipper from like almost 6 months ago because I've been too lazy to update it, which I need to at some point. But all my other printers run either Fluid or Mainsail. I like to try running both of them just so I can keep up to date with both, because dev life. Rock is life. Good luck on the mod. Make sure you share it, the Clipper mod, and on the Voron mods, and on the Voron Discord. Remy getting use of the new emojis or whatever the heck they're called. This isn't Twitch, so I can't say, you know, poggers in the chat and you guys like meme stuff constantly. So I've got a few emojis there. Tried to use Mainsail OS but couldn't make the USB Wi-Fi driver to work, so I just used regular Raspberry Pi OS and then used Kiao. Okay, that's weird. Not sure. Again, I'm not a software guy, so poggers. I don't know, Mr. Dragonite. That's what those kids say on the Twitch, right? How to jump from 3D printed object to an object that lasts, resin cast, or just cover it with resin. Depends on what you're going to be using the object for. If it's like a bracket or something, a 3D printed object usually can last quite a while. It really depends on the use case and, you know, how much wear and tear you're going to do on it. Has anyone done a switch wire conversion for the Sidewinder? I'm not sure. If it is structurally similar to an Ender 3, you can convert it to a switch wire using the mod. You may just have to tweak a few things or maybe swap out a few extrusions and sizes for beds and whatnot. Yes, I do believe there is a silicone sock for this Hotend. Mine didn't come with one, but I got a pre-production sample, I believe. So far it's working. We'll find out, you know, this is the very first print. Oh, I'm still a little, that offset's a little too low, but whatever. It's the first layer on a Vase mode print. I'm not too concerned about it warping off the bed. Any benefit to running Clipper versus Marlin? Clipper has a lot of development put behind it specifically for Voron, because a lot of the Voron dev team guys have contributed to Clipper. It's a lot more powerful in terms of adding features and running hardware. Most of us run Clipper because it works the best on, Voron's work the best on Clipper. So yeah, you can run Clipper on 1.4. Pretty much, there's like a huge, if you go to Clipper GitHub, you can see a list of all the boards that have like default configs. David's here. Hi, David. Everyone go say hi to David. Everyone say hi, David, in the chat. First layers on big prints suck. Yes, it is, David. You're just in time to watch me unbox stuff from one of your competitors. Sorry. But this first layer is taking too long. So, while this is doing that, I've got a box here for the V1.8 stuff from Fermio Labs. So let's unbox it and go through it, because there is some shiny stuff in there. Hopefully. I don't know. I took a quick look at it just to make sure everything was there, but I haven't actually gone through everything in detail, so we shall see. 26 gauge silicone wire, good for steppers. I would use 24, personally. Who builds this? It is a Phaetus Hotend, F-A-E-T... Phaetus? I don't know. F-H-E-A-T-U-S, something like that. Okay. Yay. All this stuff. Okay. So this was a care package from Germany. From Fermio Labs. They're on the Voron Discord. One of the Voron dev guys set it up originally. There we go. It's printing. So, this is Toasty Boy stuff. So, remember when I said wires? We are not going to be having a stream where I do nothing but crimp wires this time. Jody Way, 25 euro. Thank you. Appreciate it. Keep it up. I will. So, for Toasty Boy, we have a wiring loom. Now, this is the wiring loom for a 2.4, okay? But a 1.8 is a 2.4 gantry, and it's a shorter wire run. So this will work just fine. I'll just have some extra wires. But there's all your hot end stuff, your stepper motor, your A motor, your B motor. Like, it's all done. It's pre-crimped. It's got all the terminals on the end. Oh, heck yeah. So, this isn't the group buy, or I don't even know. This isn't the other harness. This is the one that you can buy from Fermio Labs. This is all. Let me pull up their site. Electronics. Where's the wiring loom? Wiring loom. I'm not logged in on this computer, so I can't. There you go. Wiring loom. So it is the Heloflon wire, whatever the heck that is. So this is the 2.4 one. So I got that. The loom, these use, on the end, they use Microfit 3 for the wire to wire. And then I think it's JST on the other end, because that's what the SKRs uses. Hopefully the Spider uses that too. I'm going to need that at some point. But this is going on a an SKR Pro 1.2, I believe I'm going to use. So put that back in there so I don't lose all these and get them all tangled. So that is the cable. This is some IKEA shit here. The cable bomb Fermio 250 ER. One stuck. So that's FEP wire, I guess. And then legit IGUS. So no China chain. I am running IGUS on Toasty Boy. Okay. It's a higher temperature enclosure. I'm going to be pushing like 60, 70 C. I really wanted to make sure I had good wire and good drag chain. So we are running, I guess, IKEA wrong country. Ah, close enough. It's all moon speak anyways. Okay. Next box. What is Toasty Boy? So Viva, Toasty Boy is my next build, okay? So I have built a V1 or V2.4 on stream, a V0 on stream, and a switch wire on stream. I haven't built a V1 on stream, so I'm going to be building a Voron V1.8. It's nicknamed Toasty Boy because it's going to be a higher temperature printer. It's not going to be a high temperature printer. I'm not printing Peak on it or Ultim or any of those fancy stuffs. It will basically just be a V1.8 that is going to be really insulated. Now, when you really insulate a printer like this, you can actually get internal temperatures of like 60 to 70 C, just ambient from the bed itself. So it's going to be a V1.8 designed specifically for higher temperatures, and it's going to have hardened nozzle in it for printing more exotic stuff. So do I know if Clipper supports the BTT? I believe it does, Dave, because as long as you know the pinout, it should work. Because if it's like the expander on a Duet, it works just fine. Tallboi, this is Tallboi. This is Tallboi. Okay, so the next box is this box. And yes, I know the colors suck on this camera, I'm sorry. So let me put this on the floor and everyone walk the dinosaur. We'll go through this one at a time. So So this is the flex plate. Now, Fermio Labs does spring steel flex plates. They laser cut them. They got the little Voron logo on it. So we got a spring steel flex plate, and it is just steel. It's spring steel. They roll their own. I'm gonna have to clean it and install the magnet on it, so I think I've done a video on that, but if you guys want, I could do another video on it, I guess. Got the magnet right here. Now, this is a high temperature magnet, okay? So this is a high temperature magnet. Let me find it on their site. Yeah, it's a Graviflex magnet made in Germany. Yeah, I don't know what its temperature it's good to, but it's a high temperature. Yeah, so it's good to 120 C. So it's a high temp magnet. So you got that. Got the magnet. Now, here's the cool part. I'm gonna try and do one side PEI. I'm gonna try and do the other side Garolite, or do a separate flex plate for Garolite, because I plan on printing nylon and PC and a bunch of stuff on this printer. So I'm gonna try and do Garolite flex plate. I think you can get thin Garolite sheets. I'm gonna give it a shot. We'll see. But in the meantime, I got this black PEI. None of this amber color stuff. Got black PEI sheets. So this is going to be a blacked out rig and a red frame. See if I can find it on the site. But yeah, you can get black PEI. So this is it right here. It's not that expensive. Tech Film PI Black with 3M adhesive on the back. Sabic Ultim, made by Müller in Germany. All this German stuff. Garolite, not Harolite. So we got that. We got that. And by the way, I paid for this. They hooked me up with free shipping, but I paid for this. Which you guys paid for with your donations and your supporting the channel and all that. So you guys are awesome. But this I haven't opened yet. This is the bed. So this is their universal Mic 6 bed. And they really packaged this. Now I don't know if this is the one they machine or it's just straight from the factory. But we'll see in a minute here. And here, printing update. It's still printing. Cool. There's the bed. So when this is an easy way to tell if it's a cast bed. If you look at it and you see the swirl pattern, that's not a straight. It should be curved. That's because when they make these by like 8x4 foot sheets, and they use a big blanch grinder that has this big orbital disc on it, and that rotates as it grinds the whole plate flat. So an easy way to tell if you have a legit cast aluminum tooling plate is you have a curved pattern to it. So that's it. So we have the mount points for for V2. We got the 3 for the 1.8, and then we have 2 tapped holes here for a ground and a what's the other one? The temperature thingy, the fuse. Now, what I am going to try and do is on the back, I'm going to drill a hole so I can put a probe, a temperature probe, directly into the bed and set screw it in. So I'll have a temperature probe giving me the temperature reading of the bed itself, as well as the temperature probe that's built into the heater mat, which I do have somewhere. It's on my thing. I got the pad already. So this way I'll have a temperature of the heater itself, and then I'll also have a temperature of the bed, and I'll put it by the corner here. So I'll be able to get a rough estimate of what the actual bed temperature is. XX Killa XX, thank you for becoming a member. And Victor, €2, thank you, or £2. Thank you, appreciate it. Have my money so you can buy more stuff. Thank you. I will keep buying stuff so I can make videos for you guys. So yeah, so I'm gonna try putting a temperature probe directly in the bed itself. I have that on V226, and it works quite nice because you can tell the bed to heat up, and then you can also know when the bed is heated up instead of guessing, because normally you're just going off the temperature reading of the heater mat. So let me wrap this back up. Print more Thangs. Thangs isn't sponsoring the stream tonight. But yes, they are a good site though. So print some Thangs. How thick is that bed? It's 5/16 or whatever metric equivalent. It might be 8mm, I think. Let me pull it up on their site, just so you guys can see. Do I have the specialized Voron heat mat? No, I just have a generic Kenobo 200mm heat mat. I'll grab it in a second. But I didn't get the fancy one. Mechanical. Yeah. So this is the bed. So it's 8mm thick. So for the bed itself, oh my, I gotta go through my. Yeah, I just got a generic Kenobo. 110 volt, 500 watt. Good enough. Every time I use things, they do have a built-in rendering engine in the website for rendering the models, so that might be the reason. I'm not sure. I've never noticed anything. And then I still have one box. Oh, I got this too. I guess they had some fun with their laser cutter, because they sent me some metal MZBot logos. David, 1999. Thank you, appreciate it. Sure, buy more stuff for my competition. I understand. They ship to Canada. They ship to Canada. I was gonna get the Jesse PLA monthly subscription, but they don't ship to Canada. Yeah, so I might give one of these out in a draw one day. We'll see. So, yeah, so I got some Voron shurikens, I guess. I got no stickers, though. I'm kind of disappointed. I didn't get stickers. So, Fermio guys, I didn't get stickers. I wanted to put stickers on the thing. Old Scratch, $20. David understands. Because I'm not convinced Canada doesn't exist. This is what you're making me do. I will drown my non-existence in some Wayne Gretzky maple whiskey. Okay? We don't exist. You don't have Wayne Gretzky maple whiskey down there. Eh. That's some good whiskey. No stickers, aw. I gotta do something. Okay, I still have one more box, by the way. Now, I'm gonna have to move the camera for this box. So, this is the big box. It's got my name on it, and it says push to open. Whoever packed this box lied. It's not push to open. It's rip and tear to open because they glued this sheet down with whatever black magic epoxy they used. Who is Wayne Gretzky? Sparta 3D is awesome. If you're in Canada, go buy stuff from Sparta 3D. They're awesome. So anyways, Toasty Boy is going to be a hot printer, right? So when you got a hot printer, you need to enclose it. Now, I could go acrylic. I am going to add insulation to the outside of it. Tallboi here is just coroplast because it's cheap. But I want to do something a little fancy. Now, if you want to get this stuff yourself, David apparently makes it at Print It Solid. So you can go see David if you're in America, and he'll hook you up. But Fermio also does this stuff too, and they ship to Canada. ACM panels. Aluminum composite. Oop, on camera. So I got the Boron logo there. It's red. That camera sucks for colors. But these are aluminum composite panels for the printer. And I haven't gone through all of these, but they're all in here, and they are well wrapped up. So if you look at it, it's basically a thin aluminum on each side and then foam in the middle. And it is rigid, it is dense, and that's gonna be what I'm enclosing Toasty Boy with. Dustin, $10. Thank you, appreciate it. We'll have to watch the replay after family gathering, but wanted to drop it and support the channel. Thank you very much. As always, if you missed the live stream, they stay up on my channel. This was a very bad model to print in Vase mode, by the way. It is not working well. Yeah, ACM. So David, I remember somebody mentioned you made them, but they wanted to do this, so they hooked me up with them. So I believe they even sent me one for the front. So I got to dig through here because I'm pretty sure they sent me one for the front. If not, I'm going to have to figure it out because I don't even want an acrylic panel in the front. I want this fully enclosed with an itty bitty window to look in. I want to insulate the heck out of this guy and have it look decent. So let me go digging through this box. I can't let these touch the ground. If these touch the ground, they get covered in dog fur and I will never get the dog fur off. Any tips on reducing resonance when using coroplast? Foam gasket around and try and connect it as well as you can to the frame. I have no idea how it will work with sound dampening. That will be interesting to see. No window, just webcam. I do want a window. I got my 2.4 panel ACM panels. Oh, there you go. Got these little guys. I think these are for, I don't know where. We'll see. And these are, I don't know what brand of ACM. Yeah, webcam would be quite toasty. And the sides. So, yeah. So let's see, I got the top. Oh yeah, and the other ones. Yeah. So we should be good there. Actually, I don't think they sent me a front. Oh well, no biggie. I'll just use the acrylic and insulate it. I can't remember if I requested it or not. I've had so many conversations with people over the past like 4 months on this build. But that's all a side view, so we're good there. Water-cooled webcam. So yeah, so we got all that for Toasty Boys in now. So all we're waiting on now is the LDO frame, rails, and motors, and we can start. Let's go look at our print. Now, this print ain't coming along too well because this egg is not Vase mode friendly, as you can see. But it's working, kinda. So whatever. It's gonna be art. It's art. I got 2 doors, check again. Okay, let me check here. Okay, so I got the side panels. Okay, side panels. Side. These 2 little ones are... Oh, there's the Fermio Labs logo. Okay, so I think this is like the... Actually, wait, let me pull up the actual CAD here. Panels. Oh, you made the hinges. You made the hinges. You went the hinge door. Okay, there we go. Yeah. You went with the hinge door. Okay, there we go. That makes sense. I'm so used to having solid front piece doors. There we go. Yeah, the narrow ones. All my printers have solid front piece doors. I have not done any with the slot down the middle. So this will be my first printer with the door. And which is good because I can actually, because it's not acrylic and you can't see through it, what I'm going to do is I'm going to cut a window out of one of these, which I got my little CNC. I'm going to do that on my little CNC. I'm going to cut a little window out and inset a piece of acrylic into one of these. And then I'll put like a gasket. So when these close, it'll be like a little magnetic gasket. Hopefully that'll keep it really tight, and then I'll insulate them. Dude, I missed that. There you go. Thank you guys. Told you to put your logo on it in a good spot, and you did. There we go. Okay, we're good. It is printing on air because this model is not Vase mode friendly. That's why it's printing on air. Yeah, Space Station Zeta. So I do the solid front door because every time I try to cut acrylic or plexiglass, it breaks. So I didn't want to cut the existing front door from my on V2.26 because that goes all the way back to V2.0 days when it was solid. And on this guy, I went cheap, and it's literally just coroplast on every side except for the top and the front, which is just a single cheap piece of Home Depot acrylic. I can go double glazing. I don't think I got to go that hardcore. So for those unfamiliar, what I plan on doing is the bottom panel and the electronics will still be ABS, and that's fine. But I'm going to be covering the whole thing in Reflectex, which is like a, you can get at Lowe's and Home Depot. Let me find it here. Dave Wilson, $20. Thank you. Appreciate it. Thanks for the videos. Encouraged me to build a boron. Awesome. That is always good to hear. This stuff right here. So this is what Eddie the engineer used when he enclosed his printers. And it's relatively cheap. $60 for a 48-inch by 25-foot roll. I don't need that much. But yeah, this is all you really need to insulate your printer, and he got it up to 70°C. So we're gonna roll with that. Just CNC the hole. That's what I'm gonna do. I got my 3018 there. I'll just hang the piece off the front. Be good to go. Just make sure you got enough clamps. See how our crap base mode printing's going. That's really printing in air. Cool. Honestly, it's a new Hotend. We know the printer works mechanically just fine. We know the extruder works mechanically just fine. At this point, we're just trying to see how well the Hotend works, which it's working just fine. It's just this model. Here, I'll pull it up here. So, this is what we are printing. And as you can see, there's a lot of overhangs here, which don't work too good in vase mode. I was looking at it like this, it looked fine. I look like this, it doesn't look fine. So, yeah. Oh well. I'm not going to start over at this point. I'm running low on PLA. I think I got more coming in next week, hopefully. I'll do a full-size, proper vase mode print next week. Start another print. Fine. Let me find a traditional vase. Vase. Okay, turn off bottom layers because I ain't gonna deal with that again. What's the print volume? 330 by 330 by about 390-ish. I'm running a 0.8. Okay. Here, we're gonna do a spiral vase. You guys want a spiral vase? We'll do a spiral vase. So, cancel the print. Pause. Cancel. Upload. I don't know what it's with my cameras, but they cannot pick up red. At all. I don't know what it is with this red, but it does not capture well on any of my cameras. Oh well. Got my first successful spools of PETG on the extrusion line today. Now testing in a few more tweaks and I'll be done. David, you come in here talking about water bottles. You come into this house talking about water bottle plastic. Unless you have a contract from LTT store for water bottles. Honestly, PTG is fine. Just don't use it in printers. I don't know if this money is envy for wishing I was in Canada or condolences money for living in Canada. But either way, thanks for the content. Rufo, $20, appreciate it. Thank you. Canada is awesome except for the nickname Canada Can't, because we can't get a lot of stuff up here sometimes. Including coronavirus vaccines right now. I got some air filtration to get certified. I understand. Hey, if you guys get some ABS going and you need a tester, you know, throw it across the Detroit River. It's not that far. Yeah, we got nothing. We got Sparta 3D. At least we can get LDO stuff up here finally. I have been denied two V Voron's #1 cereals because I was waiting on stuff from AliExpress because I couldn't just buy it off printed solid in the States or another American vendor. Yeah, there's a micro center in Detroit. I never go to the States. I never go to the States. What speed am I running? 30, I think, but I'm gonna bump it up if it handles it fine. So anyways, this is one thing I'm gonna be wanting to talk to you guys about. So I gotta start printing parts now for Toasty Boy, okay? So, I want my camera on. Hey, look, there's me too. I'm gonna be in the corner here. I'll be in this corner, and we'll do that. So there, you can watch both. Okay, so I'm doing a V1.8. This is gonna be Toasty Boy. So, when it comes to the printed parts, I'm not using ABS. I'm gonna be using not ABS. I've got CF nylon, I've got CF polycarbonate, and then I ordered, because Digimakers up here in Canada just got it in, I'm gonna try some CFPC CPE. So copolyester polycarbonate carbon fiber filament. It's supposed to be pretty good. It was kind of not expensive, so I figured I'll give it a shot. So what I'm thinking is printed polycarbonate has issues with grease and oils. So I don't want to use that stuff on any of like these components, right? XY joints, front idlers, like this part right here where it attaches to the bed because you got the bearing going through it. However, stuff like the bed mount, I'm going to try stuff that's going to, you know, upper and lower, like the rods here, maybe no, not the motor mounts, but I'm going to try using polycarbonate in a few parts. And I'm going to try the CF nylon in other parts. So like this part will be CF nylon, the bed mounts, maybe CF nylon, maybe I don't know, some of this. So I'm going to try using both. And then depending on when the CF PCE or CPE comes in, I'm going to try that. So we'll see. I expect parts to fail on this printer. This printer will be running hotter than most Vorons run. And I'm going to run it hard and dirty, if that makes sense, because I am going to want to see stuff fail on it. Because for the longest time, you know, we have data points from, you know, years ago of people trying some plastics and having issues. So there's new blends of stuff out there. I'm going to see how they run, and yeah, I'll have some stuff break, hopefully, just so we can get some data. LDO Motors, Jason, hello. Hi, Jason. Toasty Boy will be expensive boy. Not as bad because of helpful people like Jason. So that's why it's going to be like a NASCAR race car. There's going to be brands all over it. Or stickers on my wall. Yeah, okay, so everyone's like, oh, okay, so the parts are designed with ABS in mind. For the most part, you don't run into too many issues, though, when you print other plastics. Especially with the newer revisions. With the older revisions, when you had to press fit bearings into locations, there were more issues. But now it's more like you just have to drill out some holes for screws every now and then. Yes, the CNC kitchen. So he had some older CF nylon. I have, okay. So, let me pull up here. Find it. Okay, you guys advertise it, and now I go to buy it, and I can't find it. Did you makers or filaments.ca? Maybe it was filaments.ca. Can't find it. Here we go. Okay, so I've got this stuff on the way. Carbon fiber PC CPE. I figure why not give it a shot. They advertise it as being chemical resistant, so hopefully it doesn't have issues with grease and oil. We'll find out. So I have this stuff coming. I also have some Sane Smart carbon fiber nylon. Got that. Some Freeline carbon fiber PC. Yeah, got that stuff. And then also, Phaetus sent this stuff over, but for the CF stuff, I have, because I have them, and somebody sent them to me a while ago, Sigmax 3D hardened nozzles. See how they work. I have never used any Prusa filament. So I also have 250 grams of PA12 carbon fiber that Phaetus sent. And this stuff, which I haven't seen a lot of people 3D print this, glass fiber nylon. So this is PAGF. So this is glass fiber carbon fiber, or glass fiber print temp 300 to 320 C on the nozzle. So this stuff I'm going to save until Toasty Boy is up and running. I'm going to try some of this stuff on this nozzle, though, because it comes with a hardened nozzle. I'm going to print stuff with a 0.4 nozzle. All boron parts are designed with a 0.4 nozzle in mind. So I'm going to try printing some stuff on this printer with the 0.4 nozzle, the hardened nozzle, to try this hot end out with it. And then the rest of it, most of it, I'll probably print on V2.26 with a hardened nozzle in it. I can't wait till I have a printer that's dedicated to this kind of stuff, so I don't have to swap out stuff on my workhorse printers for this stuff. So, Rex Element. So when I print stuff, it's in this room. All the doors are closed. Well, the door is closed. The vent's blocked. So everything is contained to this room, and it's in the basement. So. When dry box. Ah, good point, Andre. I gotta build a dry box. I completely forgot about that. The Saint Smart CF. I'm gonna start printing some stuff this weekend. In terms of dry box, I've got this guy. I might turn it into a dry box. Well, I already use it as a dry box. It's a plano field box shell case thing. But it's got a gasket in it already. And what do I got in here? Oh, Matter Hackers Pro Nylon. I completely forgot I had this. And iPrint 3D PC Plus, which I completely forgot I had. So this holds 2 spools. So what I might do is just drill 2 holes and put some boating connectors in and use this as a dry box with a filament holder in it. So I might use this as a dry box. I got a big bag, old bag of desiccant in here. So I might use this and turn it into a double feed dry box. We'll see. We shall see. Oh, yes. And then Matt Lamb, he brings up a good point. I need to find a source of Delrin in Canada. I can find it on Amazon. They sell like half-inch blocks, half-inch thick blocks, but it's like 6-inch by 12-inch, and they want like $50. I tried getting a hold of a local place for it, but I didn't hear back from them yet. But in terms of Toasty Boy, so for those unawares, I have this guy here. If you haven't watched my video on it, go watch my video on it. But I have a 3018 Pro, the crappy little CNC from Banggood. It's like $200. It's a good entry level. Hey, I just want to learn how to do CNC. So it has no problem cutting plastics. It cuts plexiglass just fine. So what I want to try and do is try and machine some of the parts for Toasty Boy on it. So let me see here. Where is it? It's under bed. Isolate. I see. So this part right here, for example, this would not be hard to machine. It's 12 millimeters thick. So if you had half-inch Delrin, and so you would just machine it like this, single setup operation to machine the step down and then these holes, and then you just flip it over and you just hand counterbore these. So something like that I could easily machine on this machine if I could find some Delrin. But if you want to use plastic, how do I unisolate? Control Z, Control Z. If you want to machine parts for a printer, Delrin is a very attractive option. Delrin, plexiglass to a little bit. You want to use stiff plastics. You want to use hard, stiff plastics. Now, I have some stuff that I found in the bin. I've got these. I think these are PVC though. I think this is high density. I don't know. It's labeled as anti-static. So that leads me to believe it's like a PVC of some sort. And it also like cuts like crap on the bandsaw. I have these blocks, which I don't know. These are also like a hard plastic. These might be Delrin, but they're white. I don't want to use white. And then I have some ultra high density polyethylene or something like that. I think it's the stuff they use to make like cutting boards out of. So Johnson Plastics sells Delrin in Canada. I'll take a look for them. Klaus, the problem when you anneal plastics is dimensional accuracy goes out the window completely. So you would have to redesign all your Voron parts to take account for shrinkage when you temper them. And you're going to have to redesign every part in the X and Y, just not a matter of making it bigger, because it's going to shrink different rates based on X and Y size and all that and hole location. And usually it's still not worth it. Yeah, I know Delrin's like the brand name. So. Yes, UHMW. That stuff. I've got a block of it somewhere, or a sheet of it somewhere. So I have some plastics. When I get some time, I want to play around with that and see how well it machines. So, like, I plan on printing everything out of plastic, like printed on printers, and then maybe try and swap some parts out. We'll see. Granger for Delrin. I think Granger only carries Delrin in rod form, though. At least last I checked. I've never tried casting. I've never tried printing something like lost PLA casting. I haven't tried machining Delrin. I've tried plexiglass. It machines plexiglass just fine. I got some single flute carbide end mills. Oh, okay, my monitor turned off. I got some single flute carbide end mills that work really great with plexiglass. I'm hoping either tomorrow or Sunday to try machining some of this plastic that I got, this high density plastic, just to see how well it actually cuts it. So. So we'll see. But that's like I'm not going to try it and do it all this week because I got to print all the parts for Toasty Boy now, which I should probably look at the manual and see what parts I should be printing first. Because I don't know. There you go. Hey, it's printing base mode. Still got some disconnect in a few spots. Oh well. Delrin cuts 3 times better than Plexi. Well, if I can cut Plexi just fine on it, then I should have no problem with Delrin. So yeah, so let's take a look here. So this is the V1 manual, which I don't think I've ever actually gone through it. Okay, so build the frame. These are the extrusions I'm going to need. So it looks like the frame and then the gantry stuff. So I'm going to try and get everything printed this week. We'll see. But I know now I got to print the gantry stuff first. So first I got to actually figure out how well my printers print this fancy stuff. No problem, Sean. ACM, I don't know how well ACM will work as a printer component. Usually it only comes in the one thickness. I don't think you can get thicker ACM, because it's usually just panels. Like, it's meant to be panels. And these panels are probably 3 mil thick? 4 mil? Yeah, 3 mil. It's only 3 millimeters thick. And it's the only downside, it's shiny. Like, it's shiny black, so it is going to collect all the fingerprints. All the fingerprints. Oh well. It is what it is. Did I see the V1 tool changer? I believe I did. I'm not huge on tool changers. Like, tool changing is not really my... I still think it's a very niche thing. Like multi-material. I got my switch wire set up for multi-material. I don't use it too often. So. One side is shiny, one side is satin. Oh, I'll have to take a look. It's still got the protective film on it. I don't want to take it off until it's on, because I know I'm going to get it all covered in dog hair. Can I buy from McMaster? I think you can kinda, but it's a pain to get them to ship to Canada unless you have a business. Which I think I technically can get one. We'll see. Okay, now it's laying down some thick layers. Here. Let you guys watch. Any reason for such slow? It's a high flow nozzle. I wanted to see how it performed, like right off the bat. Now, as you can see right here, it's starting to taper up. See the gaps at the bottom? Basically, I'm waiting for it to become more consistent in the extrusion. I don't want as sheer of an overhang because I'm about to crank the speed up actually. So right now it's running 30 millimeters a second. I'm going to crank it up to double that. So. How many watts? It's a 50 watt. Mine didn't come with any heaters or thermistors. I just used the off the shelf that I had already. So I think we're okay to crank the speed up a bit. So control. So right now we're at 100. Let's try 125 for a bit. The Enraged Rabbit project. I don't think I'm going to dive into that anytime soon. I have quite a bit on my plate between Toasty Boy and the CNC stuff. Because I've started to kind of order stuff for Avro. So. Line width, 0.6 millimeter height and a 0.85 millimeter line width. It's a 0.8 nozzle though. But yeah, in terms of Toasty Boy, I got some ball screws in, or correction, Avro, I got some ball screws in. Do you think the 400 millimeter is as good as smaller ones? Where do you see the limit? Okay, so just to put in perspective, this is 330 by 330 by 400-ish on the Z. I can push up to about 385, 390 before stuff starts crunching, because this frame is originally a V1 frame that I converted, and this was a 300 by 300 by 400 V1. A V2 scales better on the XY than the 1.5, so I get an extra 30 millimeters. So my bed on this is a 12-inch bed. I can actually put a 13-inch bed in here, but I just haven't replaced the bed because I'm not gonna go buy a whole new bed, flex plate, and heater just for an extra inch on each side. I don't use the full bed on this much anyways. And then height-wise, this is about 380, 390. So this is a big printer. So for 400 millimeters, you are extending that another 60. So it's going to come out to like here. That's a big printer. Personally, I wouldn't go beyond 350 on the X and Y for Core XY, just because of belt length becomes an issue at that point. And then improperly keeping them tension. On the Z, with the 9mm belts, I'm having no issues with the 400mm of Z. Would you ever put a 70, 100 watt? There's really no point going with the higher wattage heaters. Like, this is a 50 watt heater, and I'm having like I'm having like less than a half a degree temperature fluctuation. So a 100 watt heater would be zero benefit at this point, because you're pumping more heat into something. You have the capability to pump more heat into it. However, unless you're sucking out that much more heat, it makes no benefit to having a larger nozzle other than EPing, right? Other than, oh, I have a 100 watt nozzle, but you can't. Even when I was printing at what, the 1.2mm nozzle at what were 40-50mm cubed a second flow, I wasn't having temperature fluctuations more than a degree, and that was with a 50 watt cartridge. So there's no point going bigger unless you're seeing your temperatures drop so much that the heater cartridge can't keep up. Copper blocks eliminated a lot of the problem that aluminum block has of temperature loss. So. Are there any tutorials for setting up extra temperature sensors? So how I did it on V2.26 back in the day when it ran duet, I just told it had a second nozzle. I just told it had a separate hot end, and I just never assigned a motor or anything to it. So extruder number 2 was my bed, and I just renamed it to bed. So it would just assume that it was a hot end in the firmware, but I never used it because everything was always T1. So that's how I set it up as the second, as another temperature. Okay, so let's go 150. Did I manage to run the H2? Yep. I printed a spaghetti detective back there. So the H2 is working right now. I still, unless you absolutely need the size and weight, I'd get an LGX over it or any other extruder. I think it's way too niche of a item with the quality issues to be worth getting it for most people. Unless you absolutely need an extruder in that form factor, in that weight, in that size. So. Tips for a good material to reinforce the top of your printer? More aluminum extrusions. All the aluminum extrusions. More struts, too. More struts. You can never have enough struts. Okay, so 150 millimeters is fine. Try 175. Let me bump the flow rate up a bit. Go 110 flow. So one thing that we are kind of worried about this nozzle a bit is airflow. As you can see, the ducts are quite a ways bit away from the nozzle itself. So I have no idea how airflow is on this thing. Like it's a total crapshoot how much air we're getting, how much cooling we're getting. Yeah. Stay hydrated. Okay, as I take a drink of whiskey. And water. Watched all 6 of your 3-hour V0 build videos, ready to start mine. Good luck, man. Was it really six 3-hour videos? Yeah, I guess, yeah. Yeah, if you don't count the video when I took it apart. What about the Orbiter? I'm hoping to get my hands on one. I think Jason was gonna send me one or may send me one in the future. I'm not too sure. I don't know what printer I would put it in though. Maybe on the Ender. Maybe I'll save it for a Legacy. I kind of want to do a Legacy at some point. Because after I build the V1, that'll be the only Boron that I don't have. Because there's 5 Borons. There's V1, V2, V0, Switchwire, and Legacy. I have a 0, I have a V2, I have a Switchwire, I'm building a V1, and then I won't have a Legacy, so. Gotta catch them all. What are the speed settings for the perimeter? They are 30 millimeters a second, because I forgot to bump them up from last week, or the week before, when we were printing with a 1.2 millimeter nozzle. So right now, this is 30 millimeters a second running at 175%. So let me bump it up again to 200%. So this will be 60 millimeters a second at 0.8 millimeters, which, let me check here, print settings, speed. Let's see, how much flow are we putting out? So according to Prusa Slicer, flow at 60 millimeters a second. Where's volumetric flow rate? We are looking about, judging by that color, maybe 25, 30 millimeter cube. We're not quite pushing it to the max. Print ain't coming out too clean, but base mode with all these direction changes at these speeds usually don't come out too well. So let me drop it back down because it looks like 200% might be too much. Go back down to 175. Yeah. Yeah, we're getting curling. Yeah, you can see the, with the high speed, those corners ain't coming out square, they're coming out rounded. So, drop the speed down to 175. Can I use hairspray on my Ender glass bed for ABS printing or ABS slurry or PI? I run PI on all my machines. That's my go-to. ABS slurry, I think, is better than hairspray with ABS. I haven't printed ABS on anything other than PEI or the glass beds with that carbon fiber whatever on it. PCTG. What is PCTG? The polycarbonate? So PCTG looks to be something from Essentium. It's like an in-house brand. Okay, they keep calling it PCTG, but they don't actually say what PCTG is. What the heck is PCTG? And it looks like some brand, in-house brand, frou-frou stuff. I can only find one company that makes it. Called Essentium. Polychlorohexylmethylene, blah, 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 blah. Words. It's a polyester. And honestly, if it's kind of like if it's honestly like PETG, it'll probably still have the same creep issues. But yeah, it honestly, I can only find one company that makes it, and it seems like an in-house brand thing, so I don't know. Okay, if the melt point's under 80, then you're gonna have issues on a boron. It's not just glass transition temperature, it's also the creep issue. PETG, in a warm environment with consistent strain on it, like tightening down a screw on like a bed mount or on a motor mount, over time, the plastic will flow out from under the screw due to the tension, and you'll have a loose screw. That happens with PETG, it happens with PLA. It doesn't really happen too much with ABS. That's why we recommend ABS. Papa Foxtrot, I am trying to think of a good test rig that I can print up quickly, that I can do creep tests with all the different plastics. I think Stefan will probably beat me to that though, because he mentioned that in his V0 video that he had that issue, so he's probably going to try. The problem is, you have to really test a lot of different manufacturer filaments too. Printing ABS isn't hard. I have a video series on my channel on how to do it. Honestly, as long as your printer has a full metal hot end and you can put a cardboard box over it, you can print eSun ABS Plus, no problem. My opinion on bimetal heat breaks, they're awesome. I like bimetal heat breaks. They work great. ABS Plus doesn't have quite the temperature resistance of pure ABS, and it's not quite as stiff. However, they are close enough that in most use cases, it's not really an issue. For example, wrong button. All my printers, all the black on all my printers, every black printed part is eSun ABS Plus. That is my go-to. I need to print ABS and it works. Plastic. So, accents are everything from KVP to Kodak to whatever. Matter Hackers, blue on this guy. But yeah. How much is the max volumetric flow? I couldn't find it in their documents. But it should be, if somebody wants to do the math to find out, if somebody who's like knows math, okay, at a 0.8 millimeter nozzle, how many millimeters a second of feed is like 50 millimeters cubic? I think it could do 50 millimeters cubic. Where's flow? Is there a calculator online for how to check that? There's got to be a calculator. There used to be like a flow calculator, right? Right there. Not flow rate calibration. I want to know if I tell it to extrude 5 millimeters a second, how much flow is that? I'm not talking layer head. I'm talking if my nozzle is sitting there just sitting there in the bed and I want to push through 50 millimeters cubic a second or a minute or however it's measured of plastic, how fast do I got to extrude? Because right now we're doing about 35, 30, 35, and it's fine. I have a favorite printer, Voron V2.4. My specific favorite printer is the guy back here. That is V226, that's my workhorse. 100 millimeters a second. Yeah, that's quite a bit. So pi times nozzle diameter, 0.8 times 50, 125. That doesn't make sense. I shouldn't be okay. So 125 millimeters a second is quite a bit. Second. Okay, so if I do, yeah, so if I'm extruding at 50 millimeters a second, it's 25 millimeters cubed. Okay. Yeah, this is a copper nozzle, by the way. Yeah, Duff, I honestly shouldn't have asked this question. I'm not a fan of the maths either. All I know, it is fun watching this do that. School cam. Okay, let's do some speed tests here. Okay. So, delete. Let's pull in a, we're not going to do a ding ding. Okay. Let's do the ringing tower. So if I do, okay, so if I do the ringing tower at 100 millimeters a second, that is 39 millimeters cubed a second flow, okay? So, let's cancel this print. Speed back down to 100%. Flow back down to 100%. Okay. So right now, we are doing 100 millimeters a second at anywhere, so 2kxl, 100 millimeters, okay? And according to Prusa, we are pushing 39 millimeters cubed of flow. So let's see how well this does. This actually is holding together. This is actually a proper print. Unlike that first one. Well, the question I was asked, so I'm just going to try the print here. But the question I was asking is if like the nozzle's just sitting in air and I tell it to extrude filament at, you know, how like you can extrude filament at a feed rate of how many millimeters of filament per second. Usually it's like 5 in like Clipper. How much do I got to tell it to extrude at to get 50 millimeters of a second or 50 millimeters cubed a second flow rate? Dust Boot, it's running Octoprint because I haven't touched the Clipper install on this printer since I built it back in October, and I want the time lapse because every now and then I do time lapses on this. But see here, like fluid, how it has extruder speed. If I set this to what number do I need to set this to with a 0.8 millimeter nozzle to equals 50 millimeters cubed a second? That's what I was asking. But instead, we're going to try a print here to see how it does printing at those speeds. We shall see. What do I do with unfinished prints? I throw them in the garbage. So 50 divided by... calculator. So yeah, so if I were to extrude at 20 millimeters a second, that would be 50. But this should be pretty much close enough to get us that number. So I am printing with a brim here. Is there a difference between bimetal heat breaks and the slice hinge? So a bimetallic heat break is a bimetallic heat break. Usually it's a stainless steel, copper, or surgical steel, or what is it? A surgical stainless steel tube with copper blocks on each end. Half of it screws into the hot end, or the heater block, half of it screws into the heat sink. Yeah, right now we're just trying, we're just running with what Bruce is telling us for speed per extrusion right now. How's the weather there? It's getting better. Squish this a little bit. Okay, so we're already losing it. Cancel. It's not even sticking. Okay, so we're just going to do the extrusion test. So, 4 Z motors. Not enough squish. Yeah, and it wasn't sticking to previous layers either. So let's see here. So if I go up. Okay, so what I'm going to do, I'm just going to do this the easy way. So according to Buddy and his math, if I extrude at 20 millimeters a second right now, that's the equivalent to 50 millimeters a second cubed. So G1E 100 millimeters, F 1200. So let's see how well this does. Oh, oh, she's skipping. That is a fat extrusion. Okay, let's try 900. Try 15 millimeters? Yeah, 15 millimeters a second. Terminal, go. It's like a sausage extrusion. Focus. Okay, so when you tell it to extrude through a 0.8 millimeter nozzle at 15 millimeters a second, it comes out at 1.7 millimeter diameter. So I can feed this right back into the printer. Okay, let's try 10 millimeters a second. So, by the way, when I was testing extrusion with the BQ H2, if I tried to extrude 100 millimeters of filament at 5 millimeters a second, just like swapping between filaments, that's normally what I do to purge any remaining filament, that was stalling out the heater block. It couldn't handle that. Yeah, so it has no problem doing that. Yeah, 41 millimeters a second would be a little too much. We're not pushing that. So yeah. Well, it out extrudes the stock V6, put it that way. Okay, let's try that ringing tower again. Try the ringing tower again. I'll put more squish and I'll start out slower and then we'll ramp up to the speed. I'm already printing 8 PLA at 220. So I'll try the ringing test again to see if we can get close to that 40 millimeters a second if we have a proper layer adhesion. And then this will probably be the last thing for the stream. We're coming up at 3 hours anyways. I like to try and keep the streams to around 3 hours. And then again, hopefully this is the last variety stream that I do. Actually, what I want to do is turn the fan on and see how much air I'm getting through here. Fan on. Oh, too late. And off. Use somewhere. I'm not using a PT100. Toasty Boy will be using a PT100 though. Start a new stream. I'm not going to start another stream. You guys want me to just stream all night? Nothing like spending 6 hours with a bunch of people on the internet. Hey man, I used to play World of Warcraft. I know all that. And EVE Online, so I know all about sitting around for hours doing nothing online. Can this do 60 millimeters cubed a second? With the 0.8 millimeter nozzle, we're having issues pushing 50. But I can see that because the nozzle is so thick, so much plastic's flowing through it, it's sucking the heat out. But we'll see. I have to squish that down a lot more. More squish. Or squish. Really squish it down. Yeah, this has belted Z. It's got 4 motors in each corner, 9mm Gates belts for the Z. Run the whole bottle here, man. Ship spin. Whoa. There we go. Yeah, it's just the acceleration test print. and we're gonna speed it up and see how fast it can extrude. Yes, audio's back. So it's set at half right now. So right now, I'm gonna let it go a little bit, but this is 50 millimeters a second at 2K XL with a 0.8 millimeter nozzle. So it's sliced at 100 millimeters a second. I'm running it at 50% speed right now. What do I think about the motion system for the Ender 5? It's a basic Cartesian box frame printer. It works. Okay, let's bump it up. So if this is 50 millimeters a second, here's 65 millimeters a second. So a 0.6 layer height might be too much. Let me bump flow up. Because it's not, the previous, or the new layers aren't sticking to the previous layers. Yeah, a 0.6 layer height's probably too high for this type of testing. You can see the print's already, it's going to garbage already at 65. So if we go back to 50, and see, that's another thing people don't realize with these high-speed printing. You have to print at like a low layer height, because when you're pushing out like 0.6 layer height at like a 0.8 nozzle at high speed, it just doesn't stick to the previous layer at high speeds. Like it just drags. It doesn't really squish into the previous layer. So with these super high speed prints, a lot of the time, if you want to print something quicker, it's better to print slower with a fatter nozzle at a higher layer height than print fast at a low layer height. That's why you see a lot of these really high speed printing tests. They're done at like 0.1 millimeter layer height. So yeah, the fan's cooling. I don't know how well it is. Again, this is a very beta Hotend mount. So I don't even know how well the cooling is on this. So yeah, I think that's enough testing. I'm not going to run a whole gamut of tests. We're going to end up stream soon anyways. Control. Get out of here. Bed. It's late on a Friday. What I am going to do is see how good the part fan is actually working, because I have no idea how well the part fan is working at this. Oh, wait. Speed back to 100%. What is this? Ain't nobody got time for this slowness. Need way more height at thick layers. Yeah, and this is already printing PLA at 220. Okay, let's see here. Move that to the front. Oop, no, to the front. Okay, up. Okay. Fan on. Eh. You're getting some airflow. Like, airflow ain't the greatest, obviously. What do I got? Do I got a piece of paper? I don't know. How are you supposed to test airflow again? Like, there is airflow. It's not really super directed right underneath the nozzle. It's kind of just over the whole area, but it's good enough. So yeah, Phaetus Dragon, I unboxed some parts for Toasty Boy. So next week, guys, I'm gonna call a stream here. That's pretty much it for tonight. Don't think I can drag this on much longer. So, next week, hopefully, I'll be unboxing the frame for Toasty Boy and putting that together. So that is what the next couple streams will be, is building another printer. We're going to be building a V1.8. If you want to build and follow along, hey, good on you. For anyone who donated to the stream tonight, you guys are all awesome. Anyone who subbed or became a member of the channel, you guys are totally awesome. Thank you for supporting the content I create and the things I do. Hope you enjoyed the stream tonight. We took a little look at the Phaetus Dragonfly HIC Highflow Hotend. I'm not sure what the HIC stands for, but it's a little interesting design for a high-flow hotend. Uses a integrated heat break in the nozzle proprietary design. I'm still not sold on it, but I'll do a bit more testing on this over the coming days. See if we can actually see what the actual capabilities of this hotend are long term. I'll put some stuff to test the hardened nozzles through, like some CF stuff. So anyways, it's Friday night. Hope you guys enjoy the rest of your weekend. You got 2 days now instead of one. Normally when we end the streams, it's Sunday. If you're on holiday, enjoy your holidays. Be safe out there. Wash your hands. Have yourself a great night. Take care.